All right, so recording's on, so I'm gonna go and start this lesson. All right, so like I said, this is 2.2, functions and graphs. Now, we'll say the graphing in this section, they give you a table already with the values in it. So you just got to find what the Y values are and then graph when we get to that. So y'all, first definition is of a function. So y'all, a function is a correspondence in which each member of the domain, which is our x's, has one and only one member of the range, which is my Y values. So a correspondence. Whoops, that should be a C, correspondence, in which each member of the domain, and like I said, y'all, that's your X usually, has one and only one member of the range. And like we said, that would be most often your Y variable. So the domain in reality is what we would call our independent variable, because we can pick any X, but the Y is called your dependent variable. It depends on what X's you pick, okay? So I'm going to give you a few examples and we're going to determine if we think these are a function or not. In an example of a function in the real world for y'all would be your paychecks. If you work a certain amount of hours, you expect a certain amount of pay. We don't want to give our bosses a choice of what they're going to pay us, okay? All right, y'all, hang on. I got to let one in real quick. Where'd it go? Okay. Okay, so I'm going to draw what I call a table. So for my first one, I'm going to put my domain in the first column and my range in the second column. And I'm going to relate them by using arrows. So for my first one, my domain would be 18, 21, and 14. My range is 21 and 7. So 18 points to the 21. That means if I had an X value of 18, my Y value would be 21. 21 points to 7. And then the 14 is going to point to the 21 also. So y'all, if you want to chat an answer, do y'all think this is a function based on what we set up here?
Yes.
Definitely, right? Because you only got one arrow coming off of every one of these members in your domain. So good job. So everybody with me on those? All right, so I'm gonna throw a little bit of a curveball here. My domain will be -3, 1, and 7. My range is a 5. All three of these are pointing to the 5. So y'all, the question, is this a function?
Yes.
Oh, good job. Y'all rolling tonight, ain't you? Good job, because every one of these is only pointing to one number. So talking about my paycheck function a while ago, This would be like a salary. You can work different hours, but your pay would be the same because you're on a salary, right? All right, y'all, let's see. Just have to let one, every time you see my hand going up, I'm probably letting someone into the class. All right, so my domain and range. This time I'm going to use cities and teams, okay? So my cities are going to be Atlanta and New York. So they're playing the place of my domain and my range over here. I got Hawks, Braves, Falcons, Knicks, Mets, and Giants. So each one of these cities is pointing to 3 teams. So y'all, is that in the function?
Negative.
Oh, I couldn't understand what y'all said.
No.
Good job. Not a function because all my domains, if this was numbers and it was pointing to 3 different choices. Remember up here, we said the X cannot have a choice, right?
Right.
All right, y'all, so I'm gonna flip over and we'll get into what we call function notation. Oh, let me show you another way. So these domains and ranges, if you wrote these out as points, like this would be what, an X value of -3, Y value of 5. This would be an X value of 1, Y value of 5. This would be a X value of 7, Y value of 5. So what I'm going to do is write a problem out using points instead of the table, okay? So let me see, I want 0, 5, 1, -2. Oh, how about 2, 7? And then I want 1, 8. All right, y'all, if it's in this form, is this one a function?
No.
Y'all said,
Yes.
so it sounds like I'm getting a no and a yes, right?
Wait, it's a no though, right? Because the second and the fourth one, the domain one is pointing to a range of -2, and then the
Yeah.
fourth one, the domain of 1 is pointing to, right?
Exactly. So that makes that a big,
No.
good job. Because I wasn't worried about what the Y values had for their X's. We were definitely, like you said, about these X values. And the only way that could be a function is if this one had 1, -2, and then you might have rewrote it again, 1, -2, okay? Well, man, y'all on a ball tonight. So y'all don't mind functions, apparently. It's a graphing, I guess. All right, y'all, hang on. I got one up here trying to get a hold of me on the email. So let me see. Okay, Tasha, I hear you. That'll work. All right, I'm just gonna tell someone real quick. Let me answer this text real quick. So let me ask y'all, did y'all use my Blackboard link to get into this class, or did y'all use the email link?
Blackboard for me.
Okay, because I got one thing that came in, and it was asking them.
Blackboard.
it was asking for a password, but once you click that link, it should be putting you in a waiting room, right? And then I allow you in.
Well, it took me 3 days to get
Yes.
in.
I have to. I'm on my phone right now using it
Okay, so,
because it won't let me use it on my laptop.
yeah, I guess it makes a difference whether you're on the apps or whatever, I guess. Alrighty, so hopefully we can get them all in. All right, y'all, so I'm gonna look at what we call function notation. So y'all seen this before. This is the f of x stuff. And basically, this thing is the same thing as y. But given my function notation, it's sort of what we would consider, say, shorthand for math. Instead of me saying, hey, I want to evaluate this equation for x value of -2, I can use function notation, which lets me know I got a function. And then since the variable is x, I can just say f of -2. And that would tell me that I'm putting -2 in for the x. So this is just symbolism. It's not part of the actual expression. It just lets us know that the expression is a function, okay? So the thing about this, if there's a value listed inside these parentheses, parentheses is a long word. If a value is listed inside these parentheses when I'm in function notation, then that value is substituted for all x's in the function. Or if this was, say, science, and you had something like a f of t. A lot of times in science, they'll use t for temperature as their variable. So then you would replace the t with whatever was inside the parentheses if t was your variable. So I'm going to do an example, and then probably, I think on this first example, y'all start getting the hang of these. So they're going to give us a function. So we're going to have given, and they're using h on this first one for me, h of x equals x plus 13. So if this was like a function in the real world, this might be a function on how I could find the height of something. Given x and then adding 13 to it. But it could be for anything. So here we go. They want us to find h of 0, h of -1. All right, let me see what that chat's got going on. Yeah, what I'll do, someone's asking about watching recording later. Y'all, once I get our class shut down, I'm going to upload this thing to YouTube, and then I will send y'all an email with the link to get to it, okay? All right, let's see. They want me to find h of 0, -1, h of -3, h of 7, and then h of c plus 15. So let me tell you, since I got 5 h's here with values in them, this is like doing 5 problems for this one example, okay? Because each one of these is going to be their own problem and their own answer for us. So let me start with h of 0, and then I'll sort of have y'all help me through some of these, all right? So for h of 0, they want me to put a 0 in for that x. Since x is my variable, I'm now going to put a 0 in for the x. Now remember, this sign's just symbolism, so we don't do nothing with it. All we got to do is figure out what we're getting over here. So y'all, 0 plus 13 would give me 13. So first answer done. So now y'all got an H of -1. So how you starting that out and what answer?
12.
Okay, so right answer. So what'd you do? You just put a -1 in for that X, right?
Oh, right.
But you're perfect. -1 and 13 gives me a big O 12. So this is really what you would call plug and chug. You plug a number in and chug on through it, then you plug another one in and chug on through it, okay? H of -3, so we're gonna put that -3 in, plus our 13. So that give me what, 10, because 13 minus 3 is 10, and then you give the sign of the larger number.
Yes.
All right, so that's negative numbers. How about this one? It's a positive number. What you doing with this H of 7?
20.
Oh, I think I heard it. What y'all say?
20.
Okay, so yeah, same thing, right? Although it's positive, I'm just gonna put a 7 in for the X. I'm gonna try to trick y'all up on that last one, okay?
So with the 7 being in the first X spot, we don't do anything with that.
Yeah, I'm confused with that actually. So
This
is it
X-
H times 7?
Do what now?
I thought parentheses, like when you have the H or you have any kind of variable there before the parentheses, and then you've got that, does the H, I'm pointing at my screen, they can see me pointing at it.
No.
I thought it would be like H times 7. So, or does the H
no,
just
no,
tell
no.
us that?
Y'all listen here. Listen here. All this is on this left side. This ain't multiplying no H's times no 7. All this is telling me is that I got a function named H, and we're putting that 7 in for those X's on that function.
Oh,
All we work is the right side of that thing. This is just shorthand saying, hey, you got a function. I gave you a function H while ago, right? Right here, I gave you a function H, right?
mm-hmm.
And they're saying you're gonna put a 7 in for that X and tell me what you get.
Okay.
Right here, I had a function H, and I wanted you to put a 0 in for the X. All we work is that right side when it's in this form.
Thank you for breaking it down like that, because at first I was still worried about the other side.
No,
Right.
don't worry about that. I'm not going to divide by 7. I'm not doing no crazy stuff because this is my function over here, okay? Which means on this one, I got a H C of 15. So y'all, they want me to take the C of 15 and guess what? Put it right in for that X. So that's going to give us a C plus 15. I'll replace the X, but I still got what for that function? A plus
13.
15. So I got
So H is C plus 28 then, right?
That's it. That's it. That's all I can do to that, right?
Okay.
Add those like terms right there. And I got a C plus 28. Okay. So you just got to think about this is like I said, this is like a big Y sitting here. But it's just letting me know in this form, it lets me know what number you actually did put in for those X's, okay? So we're gonna do another one of those. And a little bit of exponent fun. I think it was Desiree earlier, or let me see. Sylvia was asking me about exponents earlier, so here it goes.
Yes, that was me.
I got an f of x equal to a x to the third. Now they want us to find f of 0. Ooh, this one got about 5 or 6. So let's see. F of -1, f of 4, f of 8, f of a -2, and then f of a -3a. So that's what, 1, 2, 3, 4, 5, 6 little problems here. So let's start out f of 0. Over here, I'm going to have what?
Well, it's going to be
Zero.
0 because it's
Q.
0 times 0 times 0,
There
right?
you go. So I'll start out just throwing my 0 in for the X like y'all said, and then remember exponent is multiplying like y'all said. And all them zeros do give me a big 0. F of -1 will be a -1 to the 3rd power. So first of all, I want y'all to think about this. That's gonna give me 3 negatives. So what would my final sign be?
Negative.
Negative, right? 2 of them will make a positive, but when you multiply that by the 3rd one, so we know for sure that's negative. And then 1 times 1 times 1.
1.
That's a good thing about 1. To any power, it's just a 1, right? All right, y'all. F to the 4th. That's going to be like 4 to the 3rd power. And if you
So
notice,
64.
yeah, if you notice, when I do positive numbers, I don't really worry about putting them in parentheses, but you really got to when you got negatives. Oh, and what did you just say now was that answer? I heard it. I thought you was right.
64.
64. Woo, 4 times 4, and then another 4. There you go. Uh-oh, one of y'all gonna get this, and so I don't have to get my calculator. This is F of 8, which is 8. Woo, to the
12.
So I know 8 times 8 is 64. So what are y'all getting times the other 8?
512.
512. So y'all look how quick exponents grow quick, especially when you got big numbers sitting there, okay? All right, we got F of a -2. So that'll be -2 to the 3rd, which is
-8.
good job. So I guess my curveball is going to be this -3a, ain't it? Remember that -3a has to be in parentheses and raised to the 3rd power.
So would it still be like -27a cubed?
Oh man, you're on a roll tonight. There you go. -3 cubed gave me the -27. And then remember, that's a times a times a. All that adds up to a to the cube. Good job. So remember, these exponents tell me how many times that variable is getting multiplied. That bringing back memories, right? All right, so let me get another page here. So I'm going to show y'all a formula that we come up with for science. That's a type of a function. So I'm going to have f, and I'm going to let my variable be c. That's going to equal 9/5 of my c plus 32. Do y'all recognize that formula?
Is that conversion Fahrenheit to Celsius?
Bam. Other way around, it's converting this Celsius into a,
Fahrenheit.
so this one finds Fahrenheit temperature. When we know Celsius. All right, good job. So what if I want to find it for, say, we're going to find it for -15C. So we're going to find the Fahrenheit. When Celsius is a -15 degrees Celsius. So I'm going to find, technically, I'm going to find F of that -15. So here we go, y'all. We got 9/5 of our Celsius temperature, which it says is what, -15 plus 32. Now I'm going to show y'all another way that y'all can play with these functions using the calculator on this example, because it's got fractions in it, right? So some of y'all don't like your fractions. But I'm sort of happy on this one because that 15 will divide by that 5, right? So we can reduce this fraction by dividing that negative 15 by 5, and that'll give me what, a negative 3. Sort of the same principle when you put like a 5 and a 5 and they cancel. You're still just dividing those. So let's see, 9 times negative 3 is a negative 27 plus our 32. So that's gonna give me what, 32 minus 27 would be 5. Our answer would be 5 degrees. Now watch this. I'm gonna show y'all a way you can do this on your calculator. Actually, 2 ways. So let me share the screen with my calculator. All right, so let me minimize this out of my way. So 2 ways I can do this. Have y'all ever used, y'all see down here by the on button, right above it is a button that says STO with an arrow. That's what we call the store button. And I can use the store button to put numbers into the calculator for different variables. So I'm going to use X's instead of C's on my calculator when I write my formula. So since negative 15 was the value they wanted me to put into the function, watch what I'm going to do. I'm going to come down here on the bottom and I'm going to punch negative 15. So you write the number first, and then you come down here and hit that STO button with the arrow on it. And you get an arrow on the screen. And then I'm going to store it for my X variable. So I'm going to hit my X button up there by the alpha and enter. Once I hit enter, and I get that negative 15 on the right side, my calculator now thinks my X is a negative 15. So now I can punch in my equation, which was 9/5. So that would be what, 9 divided by 5. Times my X, which I'm using on here for, it's easier to do than to see. And then it was what, plus 32. So on paper, I got a 5. Calculator's about to give us a 5. So, yo, that's one way. Now, in the future, the reason I can't do stuff on the calculator when we're going to simplify in the future, like we get an expression like X plus 5 squared or something, you can't do that on the calculator because my calculator thinks X is negative 15 now. And until I change it, it's going to keep thinking my X is negative 15, all right? All right, second way you could have done this was go to your Y equals and put the equation right here, or our function, which was 9 divided by 5. I'm going to use X again and then plus 32. Now, I don't care what the graph looks like. I want to see that table because remember that table has all your X values. So I'm going to hit second graph. And my X value was negative 15. So I'm going to arrow up until I get my X's to negative 15. And y'all look at that. At negative 15, my Y value is 5. So it's 2 ways you can do these kind of problems on here, okay? All righty, y'all. So now, unfortunately, they get back into doing the graphing. And I'm going to do a few of these graphs. So I'm going to start out with, now I will say the good thing in this section, they're giving me all the X values they want me to use, okay? So I'm going to give us the problem and the X values and show you what tool I would use in MATLAB. So they want us to graph f of X equals negative 4X plus 2. They're giving us the X values And y'all look on the table now, instead of putting y here, they're putting the f of x. Because we want y'all to realize that that's all f of x is a fancy way to say y, okay? Now the x values they gave me for this one was -2, 0, and 2. So they want me to find 3 y values here. Now y'all remember, that's just the x to the first power. So that tool is going to be a 2-point line tool for this graph. Look, they're giving me 3 points, but you only got to plot 2 of those, okay? So they say first time, I need to find f of x when x is -2. So that means I'm finding f of -2. I'm gonna take this function, -4 times my
Yeah.
-2 plus 2. All right, and all we do on these little functions here, we follow order of operation, and we don't worry about that left side, right? That just told me what the variables amount was. So order of operations, can't do nothing inside the parentheses, no exponents. So I'm going to multiply left to right. So first we multiply to -4, -2 gives me a +8 plus my 2. Now I'm going to add and get me what? A 10. All right, y'all, next we had a 0 for the x. So that would make this a f of 0, which is -4 times our 0 plus 2.
2.
Because that's gonna give me 0 plus 2, which is 2. And then y'all, how about this f of 2? That'll be -4 times 2 plus 2.
-6.
There you go. -8 plus 2, which gave us a -6. So I mean, all 3 of these will fit on there. But if you want the 2 easiest ones, it's probably the bottom 2 because numbers are a lot smaller, but any 2 of these would work. Or you could have done what? Put that in your graph, y equals on your calculator, put that in y equals. Look what numbers you get for them 3 x values, put it in here. You can even see what your graph is supposed to look like before you even went into MATLAB, okay? So I'm going to use the smaller numbers and just make this out to about 7. All right, so I'm going to use that 0, 2. So here's 0, go up 2. And then I need to find 2x and go to -6. So 2 on the x, down to 6 on the y. And y'all look at that. That's a negative exponent in front of that x. So anytime the negative number in front of the x, anytime that number in front of the x is negative, your line goes downhill. And if that was a positive 4, it would go uphill left to right. So y'all, not too bad. They gave me the numbers to pick, so you don't have to do that part. All you got to do is get the y values or the f of x's, plot them points. So let me go to the next one. Any questions on that? All right, y'all. So how about this? F of x equals -3 plus absolute value of x. They're giving me a table. This time they're giving me 5 numbers. So my x's will be -2, -1, 0, 1, and 2. So I guess MATLAB is sort of like me. They're not keeping the numbers small. So y'all remember, we said this was absolute value. So in MATLAB, absolute value has 2 dots on it. That means we only need 2 points, but it's picky. The first point has to be the middle point on the numbers they're giving you. So use the middle point of the table first. Now, the other day when they didn't give us a table for section 2.1, when we did the absolute value, I said your middle had to be what made that equal 0 in there, okay? But now they're giving you those. And you see the middle point, if you put the 0 in there, that would be 0 inside them lines, okay? All right, y'all, so let's see. Absolute value tool, so let's go. First one they want me to find, f of -2. So that's going to be -3 plus the absolute value of -2. So y'all, I'm going to give y'all a chance to work that in before I do, because I want to see what y'all do to that. And I'll give you one clue. Treat the absolute value like parentheses. So that means you're going to start with it, okay?
Does that mean that we have to turn the -2 into a +2?
Yeah, bring down your 3.
It would be
Absolute
-1.
value of any number better come out what?
Yeah,
Positive, right? Mhm. So see, I'm just awakening all y'all's memories. Remember, if it's inside here, it's coming out positive. The only way absolute value can come out, it can be negative, is if you got negatives in front of it, okay? All right, so what's that final answer?
-1.
-1. All right, so y'all, here you go. F of -1, -3 plus absolute value of -1. So what are y'all getting on that?
it's gonna be -2 then, because that -1 again is converted to a +1.
There you
Okay.
go. And you'll see on these graphs, eventually you'll start seeing symmetry on these f of x values, okay? Because if you see, this is a sharp V graph. What's next? F of 0, so -3 plus absolute value of 0. All right, y'all, what y'all getting on that?
-3.
There you go. Absolute value of 0 is a big 0. All right, what's next? F1, this will be on y'all again. So -3 plus the absolute value of 1. Now, let me ask y'all this. Are y'all getting more familiar with what I'm doing with the F's now?
Yeah, much easier.
Okay, that's
Thank
what
you.
we want to, that's the main thing we want to make sure on this lesson, okay? All right, so what's that give you?
Still gonna be a -2 though, right?
Damn. Because absolute value 1 is 1 again. So now we're starting to see a little symmetry here. So looking at that, without even doing the math, I could probably tell you what's going here, couldn't we?
-1.
Probably going to be a -1 because that's what comes next on our order. But to make it official, let's throw an F of 2 in here. So that -3, and then that's what, a 2 again. And there's your -1. So the first
And that's what,
say again.
and that's why your graph is always gonna be a right angle then, right?
Sort of like a right angle,
Well, maybe not, but a sharp angle as
but a
opposed to
sharp
like
V.
a curve. Yeah,
Because every value on this side is getting mirrored over here. Because no matter what sign it is, the X values for each side are going to have the same value. And remember, that's why the squared graphs do that. Because remember those X squareds, you're making everything positive no matter what the X value is. So that's why they sort of make a U. But absolute value is definitely a sharp V, okay? So let's see. If I'm doing that on MATLAB, I chose my V shape, absolute value tool. Remember, the first point has to be 0, -3. And they keep, I'm glad they're keeping the numbers small for us, right? All right, so 0, -3, 0 down to -3. You see, that's why MATLAB needs that point first, because it's got to know what point's going to make that mirror for it, okay? And then any of these other points, oh, I might do 1, -2. That's not bad. So go right 1 and down 2. So at that point, my line would shoot up. MATLAB would automatically mirror that other side, okay? You know, they're not too bad once you play with these graphs a little bit. You'll get more used to them tools and what points you got to use, okay? So let me turn it up and do some squared graphs. So I'm going to do f of x equals x squared minus 2x minus 10. Here comes my table. Our table will be -1, 0, 1, 2, and 3. Oh, guess what? We got an exponent of 2 that controls this function. It's the highest exponent. So since 2 is the highest exponent, this is going to need to use our 3-point quadratic tool. Don't matter if there's more x's in here. The other day, y'all had x squareds and maybe x squared plus a number. They're just throwing another x in here on you, but it's still controlled by the 2. So it's still quadratic. And remember, on the quadratic ones at this section, I think it is picky about putting the vertex first, which is going to be the center point again. So on these, whether absolute value or the quadratic, you'll always plot that middle point first, okay? All right, y'all, so here we go. We got
Someone isn't muted. The feedback is like horrible.
Oh, I'm not hearing it, so let me look. Yeah, and then y'all can just hit unmute when y'all want to ask me something, okay? Hopefully my video ain't really, I'm not hearing it, so hopefully the video's all right, right? All right, y'all, look at this. There's 2 x's in this, so I got to put a -1 in for both of those x's. So I'm going to have -1 squared minus 2 times -1 minus 10. So remember, no matter what value you put in for x, any x you squared at this point better be positive, okay? Because -1 times -1 is a +1. That takes care of the exponent first. Now I'm going to multiply. Now, if you wanted me to go step by step, I would bring everything else down. So I did the exponent first. Now I would actually multiply that. So bring down that 1. 2 negatives will now make that a positive. 2 minus my 10. And then y'all at that point, I'll just add and subtract left and right. So 1 plus 2 is 3. 3 minus 10 is what, a -7. All right, what's next? F of 0. That's going to equal 0 squared minus 2 times 0 minus 10.
-10.
Yeah, because that's a 0. That's basically going to be a 0. So you got 0 minus 10. So there you go. Now remember, with the points they're giving you, eventually we're going to start seeing symmetry on these. Because like we said, any number you squared makes them positives. So we should start seeing some symmetry in a little bit. Let's see, we got what, a f of 1, so that'd be 1 squared minus 2 times 1 minus 10. Oh, y'all, what's that? 1 minus 2 minus 10. Ooh, a lot of negatives to keep up with. So 1 minus 2 is -1. Negative
Negative
1 minus 10 is a negative 11. Are y'all f of 2? 2 squared minus 2 times 2 minus 10. You know what's funny? 2 squared, well, that 2 times 2 is also a 2 squared, right?
-10.
Technically, there you go. So that'd be what, 4 minus 10, which is a -10. Which means this last one has to equal
-7.
-7. All right, so we'll verify. We got 3 squared minus 2 times 3 minus 10. 3 squared is 9. Minus 2 times 3 is 6. Minus 10. So 9 minus 6 is 3 minus 10, and there you go. -7. So remember, first point that we want to plot is 1, -11. Then you got to do 1 on the right side in the positive numbers, and then sort of go to the left side of it and get another point, okay? So I think this one will make you plot the middle, a point to the right, and then it'll review it when you make that point to the left. All right, questions on that? All right, so I'm gonna flip over. We're gonna do a cubic one. So this will be f of x equals x cubed plus 6. So remember, the cubic tool in MATLAB is the one that looks like the squiggly line, and it had 4 points. So the 4-point cubic tool, the table they're giving me for my x values is -2, -1, 0, 1, and 2. Well, I'm happy they picked small numbers for this, because remember, that's a 3 sitting there. So remember when y'all did that 4 cubed a while ago, you was getting big numbers already, right? All righty, so I'll let y'all find me what f of -2 is. That would be -2 to the third plus 6. Now we'll say this, since this one's a squiggly line, we probably won't see any values match up over here, okay? So it's not symmetric or anything. So what y'all get on this one?
So it's -8 then because it's a cubed, -3 times cubed, +6, which means it's going to be a -2 is the final answer on that, right?
There you go. All right, we got an f of -1,
So that'll be a +5 then, right?
because you're gonna get what, a -1 here, plus 6, bam. Now how about that 0?
+6.
Because 0 cubed will be 0, good job, and 0 plus 6 is a 6. And I'll tell you all the truth. Anytime your variable is 0, the answer is always going to be that last number, because that 0 kills anything else that's got a variable in it, okay? All right, so is it going to do that on these F1s? What y'all got? 1 cubed plus 6. So what y'all get?
7.
And
There you go. And then finally, you got an f of 2, which would be 2 cubed plus 6.
14.
Oh, what y'all just say?
14.
Yeah, because 2 times 2 is 8 plus 6, and there we go. 14. So y'all doing pretty good answering me on here, so gotta have that confidence, right? Now, I will say this, the nice thing about using that cubic tool is it don't care what 4 points you pick. But since I don't want to make my graph real big, I'm probably going to avoid that 2 and 14 because I could use these 4 right here if I want to, okay? All right, so y'all, MATLAB, it does what? A -2 to the left, -2 down. I'm gonna do -1, 5, so -1 left, up 5. 0, 6, start at 0 and go up 6. And see, this number at the end is always the y-intercept, no matter what your function looks like, because that's where it's crossing the y-axis at 0, okay? And then I got what? 1, 7. So when I do my 1, 7 up here, MATLAB will come in and connect our little 9 for us. Okay, so any 4 of those would work. MATLAB will probably have this thing going out to about 20 on that problem, but I'm not sure. All righty. Next, we'll look at how to tell if a graph is a function visually. So how to tell if a graph is a function visually. So they don't want me to work no formulas or anything. They got a little trick that I can use to tell if a graph is a function. Have y'all ever heard of what they call the vertical line test? So have y'all ever heard of that?
No.
Shame on them, right? Now I will probably call this a VLT in the future. But remember, vertical line, straight up and down, right? So here's what I use the vertical line test to tell me if a graph is a function. So y'all watch this. If a vertical line can intersect a graph at any time more than once, so depending on the graph, it might intersect it 2, 3, 4 times or more. But this says if a vertical line can intersect a graph at any time more than once, the graph is not a function. Because remember a while ago, we said that all x values can only have one y value, right? So if my vertical line crosses my graph more than once, that means there's an x sharing some kind of y values, and that violates that, okay? So my vertical line, when I run it across there left and right, cannot touch that graph more than once. So here we go. Using the vertical line test, determine if a function. So this is just gonna be yes or no questions for y'all. So for my first one. I'm gonna do a graph that looks like this. So on y'all, do y'all think this graph is a function?
Yes.
Okay, that sounds good, right? Yes, because y'all watch, I'm running my pen across. It intersects at one time here at that point. It intersects at one time here at that point, and I'm looking at the V part of this, right? No matter where I go, my pen only intersects that graph one time at the most. So good job. And that better be a function because that looks like what? So what function have I been drawing that looks like a V? Oh, I got y'all stumped on that.
Just can't remember the name of it. It was the
Yeah,
one where it's
absolute
got
values.
symmetry up and down. Yeah.
Yep, absolute value. There you go. I done got y'all brains fried, don't I? All right, this one sort of looks like an oval. Is that a function? Well,
Negative.
I think I heard it, but it wasn't loud.
No.
Okay, there you go. No, y'all, watch this. When that vertical line across it, it's hitting the line up here. It's hitting the graph at the bottom at the same time. So that means that all these X's can either be that one or that one, and that violates our rules, right? Right, this one sort of curves up that way. Sort of curves up that way. Is that a function?
Yes.
Yes.
Sounds good. And that's our parabola, right? So our parabola has to be a function because we've been playing with it. And look here, only intersects it once, no matter where I get on that graph. So y'all don't remember doing that back in the day?
No.
We have to talk to them, okay. But what if I took this parabola and done it like this? So my parabola sideways, is that a function?
No.
There you go, good job.
Is there any exceptions to that, or am I overthinking this?
Oh, you're overthinking because remember, all these X's, they only get one choice. The only way, no, so let me show you what we do to that kind of situation. So say I had a graph that did a slow little curve like that on top and bottom. Those are sort of curvy, but my lines look a little straight. So an example of that is the square root, where f of x equals the square root of x. So watch what I mean. So here's 0. Square root of 0 is going to be 0 every time, right? What's the square root of 1?
1.
What's the other square root of 1?
-1.
And remember, square root undoes what can make a number, and -1 times -1 also makes a +1, right? What's the square root of 4?
2.
And
-2. Okay.
so see how this graph is going up. Every value of X is gonna have two values, right? So what we do to make this a function and useful to us, we only account for the positive square root of X. So what we would do, we would restrict any negative answers and only keep the positives. That way it would pass our vertical line test, okay? But y'all remember, in all reality, square root does. Hang on. Hey, get that dog. I have to start locking it dog up, I think. But y'all, in all reality, square roots of numbers do have two solutions, okay? All right, so what I'm gonna do here, I'm going to sort of preview a little bit of the 2.2 support homework. And I'm not going to do many, I'm just going to do a couple problems and show y'all what they want you to do in here. So these are going to say simplify. So I got n minus 8n. So y'all, what is n minus 8n equal?
Negative 7n.
Negative 7n. Good job. So we review y'all on this because a lot of times people, when they subtract letters or add letters, they want to change those exponents. But remember, this answer has to have the same looking variable when you add and subtract. And you always treat that like a 1 there, right? If there's not a number in front of the variable, it's always got to be a 1. All right, so what if I gave y'all 2y minus 6y plus 3y? So what y'all doing to that?
Negative y.
So let's see, because 2 minus 6 is what, negative 4? Good job. Negative 4 plus 3 is a negative 1y. Now, I think MathLab will let you put the 1 there if you like putting the 1 in front of the y. But the most simplest form would just be to make that a negative y. So y'all, good job. All right, 7x plus 3 minus 2x. How about that?
Is it 5x plus 3?
5x plus 3.
5x plus 3, because all we can do is combine the 7x and the negative 2x, and then bring down our 3. So, anyone have questions on those? All right, let me challenge y'all with this. Negative parentheses 2y minus 3. This one, I want you to simplify by removing those parentheses.
Would it be negative 2y plus 3?
That's what I got.
Oh man, y'all are on a roll on the support, see?
Yeah, let's
Is
do
that-
the whole class like this.
Yeah, I agree with
The
that. This
whole
is,
class.
So all good is distributing when you got parentheses. Anything in front of those parentheses gets distributed, and I'm really treating that like a negative 1. Negative times positive, and then negative times negative, okay? So y'all like this, huh? All right, we'll throw
Very
y'all,
much.
we'll throw y'all a curveball. Watch this. 18y minus parentheses 2y plus 6.
Well, can't you divide the 18y by the 2y to make it 9y minus? No,
Oh.
I don't know what I'm talking about.
Oh, no, remember, you can't divide by this stuff because this
You're
is
right,
not
I'm
an
wrong.
equation, it's just an expression. Now, if I had equals and all that, then I would have to follow the rule. What I want to do to this side, I would have to do to that side.
16y minus 6. Is that
There
right?
you go, because this would be what, 18y minus 2y. Negative and positive makes that a minus 6. And then all you did was what, add these like terms? And you got me a 16y minus 6. So y'all, that's what support does, and I'm gonna do one more to you. But that's what support does. It just sort of throws stuff to help you get better at doing the college algebra stuff.
Muscle memory.
So what if I had 3x squared minus 2x plus 7x squared?
Would you do the exponents first? So you would have 9x squared.
It'll be
mi-
it'll be 9x squared minus 2x.
10x
I'm
squared.
pretty sure. 10x, yeah, my bad.
Oh, so let me show y'all one thing. This exponent, this 3x ain't in parentheses. So since the 3x ain't in parentheses, that exponent only touches that x, okay?
Oh.
So you can't, now if it was like this, 3x squared, then you could play with that, okay? But we can't do that because this ain't in parentheses. So the exponent only affects the variable or number in front of it unless I got parentheses. So guess what? Y'all can't do nothing to that. So don't worry about exponents because you can't do nothing with those.
10x squared minus
All y'all doing,
2x.
there you go. Like terms are the x squared, right? So you can add those and y'all said what, 10x squared? And then bring down the. So can I go further?
No.
No, that's our final answer. Okay,
So if they're not in parentheses, though, you can combine the different separate parts, like the 3x square and the 7x square.
as long as my exponents match up and my variables look the same, okay?
Okay.
Yeah, like I said, if this would have been 3x squared minus 2x plus my 7x, if it would have looked like that, then my first step would have been figuring out that number.
Okay. Okay.
So that would have gave me what, the 9x squared minus 2x. That's what, 7 times 7, which would have given me what, 49x squared. But now you're back to the same situation, right? At this point, all you can do is add the x squareds to go further. So what, 9 and 49 would be what, 58 x squareds, and then bring down your 2x. But y'all, they're not going to kill y'all doing this kind of stuff. They're just going to give you something like that, and make sure y'all only add the x's that match. It's almost like if x was 5, that would be quarters, and that would be nickels. And I can only add my quarters together and then bring down my nickels, okay? All right, y'all, so let me get one in real quick. I think she's been having problems. Let's see. Oh, no, she was here earlier. All right, y'all, so that's a little bit of what you're going to see sort of doing the support. So any questions on this tonight?
No.
All righty.
I see that on the homework, it says 2.3 is due on the 28th as well. So are we doing 2.3?
Oh, I'll fix that if I got that date wrong. It should be the next section.
Okay.
So 2.3 will be what I start Monday.
Next week.
Yeah, so I'll fix that. It should be the 28th for the 2.1 and 2.2 stuff. And then I think it's like September 4th or something for the next section. So I'll fix that. Let me make me a note.
I have a question.
Mhm.
2.2, okay, that was pretty good. I can handle that. But I'm still kind of lost on 2.1 with the graphs, and I'm still struggling with that.
So those graphs are basically the same as the graphs I graphed tonight. The only difference is you just gotta pick your own numbers.
Okay, got it.
You're gonna use the same tools as the ones I used tonight on the problems that match up with those. They just wanted to have y'all use their numbers tonight because they wanted y'all to get used to the functions and see all the symmetry. But the ones in 2.1, you're just gonna pick numbers like I did the other night. Use those tools that we listed the other night and graph those in MATLAB, okay?
Can I ask you a question? So say for instance, if you know how 2.1 and 2.2 is due on Sunday, what if I still want to practice it a little bit more after the 28th? Will it be able to let me do it?
Yeah, let
Even
me,
though it's not gonna
let me pull up my MATLAB real quick, y'all. I'm gonna show y'all some stuff on that real quick. Let me get in the Blackboard real quick. All right, I'm almost there, then I'll be able to. I'm gonna go into student links like y'all would. And assignments. All right, so I'm gonna share my page now. All right, so y'all should be seeing all the problems. So I'm gonna go in there and act like I'm doing question 1 on this one. So, y'all see my question number 1?
Yes,
Is that a function?
Yes.
yes,
Okay.
No.
Oh, you were
it
right.
is yes.
Because
It's
remember,
yes.
every domain only points to one range value. Remember, the ranges can have more than one X, but the X's can only have one range. And see, all the numbers only got one arrow coming from them. So they only got one choice, so that does make that a function. So say I went in there and I done it, got it right. But let me go.
I actually started on this.
I'm gonna go
I'm
back.
sorry, I actually started on this. It was one of the questions, I don't know if it was 7 or 8 that I had problems with.
In section 2,
Mm-hmm.
in this section, so let me go to 7 or 8. But y'all, before I,
Or was that in support? No, it was this one. I'm sorry.
but here's what you see down here in the right corner. It says similar question. Do y'all see that?
Mm-hmm.
You click that. And it gives me another problem. Now, when y'all do a problem like that and y'all click it to do a similar problem, it's going to ask you, do you want to change the score with the new problem or keep the score the same? So if you already got it right, you can click you want to keep it the same, and it'll just give you more problems just to practice. Okay. Well,
But if I get it wrong, then I can continue to do problems to
yeah,
get more comfortable with it until I get it right.
until you get it right. So I could say, so say I missed it, but I've already got this one right. So let's go to, and see right here, it says save this attempt or save best score. So if you already got it right and then you miss it a couple times, I can say, oh, well, I want to save my best score. And it's going to give me my 1 point for it, okay? So y'all, let me go up the line, what we want, number 7, let me see.
Okay, no, it wasn't that one. It was another one.
Okay. Now we'll say on this one,
Pull it up.
when you put this, let me tell y'all one trick on your number 7 in 2.2, when you put that A plus 4 into here, let me work this one. So if I put a 2 in for the absolute value for that X, what's my answer going to be? So you're going to have absolute value.
-2.
There you go, because absolute value of 2 is 2, and 2 minus 4 makes that a -2. So you're going to put that in first. You're going to check that answer. Now, I didn't mind the first two parts of this, but it was that A plus 4 that I don't care for. Now, you put a 4 in an absolute value, what are you getting?
It's 0.
And y'all, so I'm gonna just tell y'all on this A plus 4, when you put the A plus 4 into this, there's nothing we can do to it. So your answer should look like absolute value of the A plus 4. And then arrow out. And put, what is it, -4. This one cannot be simplified. So you want to keep it like that when you come down and say, check my answer, okay? All right, so then let's see if it's 8. Well, that's X3. We did that one, I think. So let me go to 9. That was doing the temperature when we did one. And then it'll have a few doing the graphs, which we did. And then you ought to end up with, guess what? Vertical line test, okay? So
I'm sorry, I stepped away. Did you do the one with the decimal?
with the what?
The decimal.
Oh, that ain't bad, y'all. Let me go up here.
I was just trying to make sure I ain't get, I think it was question 6, actually.
It might have been, it's either 5 or 6. Let me see. It's the
It's
first
6,
one
so
doing
that's
it.
where I'm at. It's question 6.
Let me see. 'cause
It's
that-
the third one, like down from question 6. It's 6.3.
Yeah,
I could
I
give you the
think it's
point.
this one. Let's go through this one and work this.
Okay.
If it's 0, you're gonna put a 0 in for that X. So it's gonna be what, 0 plus 8?
It's gonna be 8.
Okay, so we're gonna come down here. I think it's this one, I hope. F of -9, put a -9 in for that X. So
No,
you're getting what?
Is that a -1 then?
Mhm.
All righty. There's one of these that had like 4 or 5 parts. -16 in for the X.
-8.
Should be coming up here. Should be. F of 7.
wait a minute, what?
So what's that? 7
15.
plus 8,
It's gonna be 15.
15.
What?
Oh
I
no,
think
oh, it wasn't this one.
I said it was question
I
6.
got my notes. Let me see.
It's
where'd the
question
notes go?
6, Mr.
And I,
Eugene.
I got the actual printout of the homework. So let me see what number does that.
It was question 6, the third one
Hey,
down.
it was 6 on mine. So let's go here.
Can you hear me?
I hear you.
Oh,
You guys are making me laugh.
So it's this one. So we're gonna find K6 first. So put a 6 in for that Y. What are y'all getting?
50.
And this
our
is gonna be
questions
three.
are different, right?
Oh yeah, your numbers will be a little different now. I will say
Okay.
this. MATLAB only has so many different versions of a problem. So
56.
sometimes you might get the same problems with me. Sometimes you might get different. Okay.
Is that -54?
58.
So we've got 7 times.
That's 58. Oh,
Negative.
shoot, wow.
Well, you're almost there because that was what, -56 plus
It's
50.
-54.
-54. There you go. Now, guess what's coming up? K of 6.2. So you're going to take the 8, multiply by 6.2, and then add 2 to that.
Can we see what you write?
Do what now?
Never mind.
Hey, now, do you got your calculator?
Yes.
Okay, watch this. I'm going to do this one on that calculator.
Mm-hmm.
So my function was what? 8y plus 2. And I'm not even going to graph it. I'm just going to use that store button. So let me get off this graph. and clear this. So y'all should be seeing my calculator now, right?
Sure.
So our function was 8y plus 2, but now on the calculator, I'm just going to use the x for my variable. But they wanted me to find k of 6.2. So I'm going to take the 6.2 and store that for my variable and then hit enter. Now all we got to do is punch in what? 8, our variable, plus 2. So this way, whoops, not 2 of them. So let me delete that last one. Oh, let me backspace. Now delete. All right, so 8x plus 2. If I hit enter, we're going to get our decimal answer of 51.6. Or y'all, that is not too bad. You could do what? 8 parentheses 6.2. Now, when they're small like this, it ain't hard to come and plug them in. Multiply with parentheses and then do a plus 2.
But you know, I was thinking fractions, that you don't like decimals. We don't like to use decimals. We like fractions. That's what I was thinking.
Well, now,
But I
it'll-
understand.
this one will actually take a decimal answer, but if you ever want to turn, you want me to turn a decimal into a fraction?
I know how to do so. I was just, I just wasn't sure before I even attempt to put an answer in there, try to answer was to put a fraction or a decimal.
Well, if they give you a, so here's the thing with MATLAB. If they give you a decimal for your X values, keep it in decimal form.
Okay,
If they do not give you a decimal, even if they just give you plain sign numbers or something, if they don't give you a decimal, then they're probably wanting you to put that thing in fraction form. Now,
Right.
now let me show you. Let me go back to MATLAB real quick. Usually on a problem like that, when I click it, well, this one ain't telling us, but in the future, it'll tell you if they want fractions by saying, hey, write a rational answer, which rational means fractional. Or it'll tell you if they want decimals. They'll usually have a little bitty sentence after the answer blanks. So right now, though, if they give you a decimal, write a decimal answer. If they give you anything else, write me a reduced fraction, okay? So I hope that answer, did that answer that? So what did we get, 51.1? I forgot what we got,
51.6.
51.6.
Okay, for me, it was question 7. It was just part C that kind of confused me.
So I think we did that just now. Let me go back and look.
Mm.
Yeah, so.
Yeah, that.
Yeah, so y'all remember, whatever they give you for your C, put that in those absolute values, and then the rest of it, -4 or minus whatever they give you. We cannot simplify that because we don't know what the A sign is in it. Because remember, yeah, so we just can't figure out the sign of the A, so it makes this have different answers, so it won't simplify, okay?
Okay.
Now, the biggest mistake people put the absolute value with just the A in it. But since that 4 is inside the bars, it won't add to the -4 that's on the outside. Alrighty, so y'all, let me stop that share. So any questions over anything tonight?
Yes, can you please, I didn't get I wasn't able to make it to the first class session because of Zoom, so I had to go up to the school and to IT, and they finally got me on.
Okay.
Is there any way I can get the notes from Monday night and tonight? Because I promise I am lost. This is Spanish.
So here's the thing. My notes tonight I'm recording right now, so I'm gonna end my recording when we're done and put this on YouTube and send y'all a link in email. For the first session that I did Monday, you're gonna go into Blackboard, click on College Algebra W04. And once you're inside Blackboard, on the left side of that, you'll see the student links for MathLab, the Zoom link for the class, course content. In that course content, when you click on it, it'll bring up the different weeks. So click on week 1 for this week. And I've got videos for everything I do for this week. I got calculator videos helping you doing that. I got lecture videos doing lectures like this that I recorded from the winter in there, okay? Or the spring.
Okay,
I just put the YouTube link to your 2-1, the one from like the winter, the one that I watched today, that more or less was what we did on Monday. So I just put it in the chat, the YouTube link for it.
Right, so,
A little bit easier path to get to it, I think.
right. Yeah, so, if you want to, like he said, you can click on that and then it'll bring your page up and then you can sort of save that to look at later. But I keep all my videos in course content going by the weeks that we're doing the work. So that if y'all do have to miss, y'all got videos, especially since last year and the year before with the COVID. I needed people to stay up when they were sick and coming back and all that, so. All right, so Patrick, good job. I see that now. All right, y'all, anything else? All right, so y'all to keep pace with my class, let me catch one real quick in here. So to stay on pace, you want to have everything up through 2.2 done, and then we'll start 2.3 Monday night, okay?
Okay.
Now, if y'all got issues, always email me or whatever, and we'll see what's up. So I'm gonna stop.
Did you get everybody's attendance for tonight? I'm sorry.